Thanks for tuning in at Brackies.
Hello everyone and welcome to this video on making a multiplayer FPS in Unity. Today we will be improving our flying mechanic by first off adding a fuel thruster amount or a thruster fuel amount so that we can run out of fuel when flying and then it will replenish when we are not flying. We will also be fixing the bug where when we fly on top of obstacles or just stuff higher than the actual ground plane, it will kind of collide with the ground instead of using that as a new base to hover over. So that's something that we will fix. Also to display the fuel amount, we'll have a cool graphic. So that's something we're also going to add. So today's video is going to be super fun and super important. So let's just dig right into it. And you can see here that I'm in my web browser, and that's because I want to mention that all of the different models we are using right now for the environment are placeholder. They're only temporary, and I'm working together with a cool friend of mine to make this environment look a lot more awesome. And if you get impatient or just want to do some of this stuff on your own, maybe create weapons on your own, a player on your own, or different environment props, you should check out this tutorial that the same friend of mine has made. It's called Introduction to 3D Modeling. It's a blended tutorial, and it gives a very practical introduction on how to model some of this stuff out on your own. And you can see here that he models a tactical grip for a weapon, so it's very relevant for our tutorial. You should definitely check that out. So without further ado, let's jump back into Unity and get started with today's subject. So you can see here that currently on our player, we have this idea of a player controller, which has a speed, a look sensitivity, and a thruster force. What I want to do is kind of expand onto this to create a limit or kind of create a fuel variable that will decrease whenever we are using our thrusters and increase when we are not using them. So to do this, let's double click on the player controller to open it up in Visual Studio, and we'll have a go at this. I also want to create some UI to display this stuff. So you can see here that I've opened up the player controller, and I think that we should maybe start by just implementing this limit, and then in a moment, actually let's start with the UI. So just keep this open. We can close the player shoot, and the actual player script will also be editing the player setup script. So I have these two open here. Good. So let's start by modeling out the UI. So we'll find our prefabs, player UI. Remember, this is the prefab that spawns in with our player to display UI only for that local player. And it currently only has a crosshair. Let's right click under the player UI, go under UI, and let's go down to find the image here. And as the sprite, we'll just go in and select UI sprite. This is a standard sprite that is included with the UI system. And we can go ahead and maybe anchor this to the bottom left corner. And we can go ahead and maybe drag this out like this, make it a bit smaller, position it there somehow. I think this looks pretty good. We can of course always edit this later. I might want it looking a bit smaller. Something like that looks pretty good to work off as a base. What we can then do is we can make this black, and we can then change the alpha here. So this is going to be the background of our thruster fill. So this is going to be the fuel or thruster fuel. And here we're going to duplicate that and drag that under using Control D and then just dragging. And we are going to have this as the thruster fuel fill. And this is going to be a much brighter color, still a bit transparent. And let's make it like a light blue. I think that could look fairly cool. Something like that, maybe a cyan color and maybe a bit less transparent. There we go. So it looks like something that we definitely want to have a lot of. And you can see what we can do now. Now we can take this and we can scale it down, and you can see kind of what effect that gives us. So that is super cool. But instead of using the height here to scale down, what we want to do is use the scale here, because that goes between 0 and 1, and this way we don't have to manage any kind of start height and minimum height or anything. We can just scale this on the Y. And to make this even easier on ourselves, we should change the pivot point. So we want it to be halfway over on the X, and we want it to be 0 on the Y. This way we can simply scale here and it will scale downwards like we want it to. So you can see just how easy it is to regulate this using this variable. Cool. You could also do a custom image type and use filled here, but the way that this sprite is set up with the borders, that's going to look super weird. So we're going to keep that at sliced and simply use the scale factor. Cool. So next up, I just want to add an icon here to display that this is some kind of fuel amount, something that controls whenever we can fly. And I found that Unity had a pretty cool icon actually that we can use. So let's right click here, go into UI and choose image. And you can of course make this yourself in Photoshop if that's what you want to do. Then let's go under sprite here and select the button accelerator up sprite. This is part of the standard assets cross-platform input, which you can of course just right click and go under import package and select cross-platform input to import if it's not already in your project. So we can take this here, we can drag it down here, scale it down, something like that, and we'll make sure to anchor this to the bottom. So if we want to change the way this looks, it's going to scale just fine. I think that looks super cool. I do want the thruster fuel here to be a bit brighter maybe. And maybe change the hue just a tad. I think something like this looks super cool, and we're going to stick with this for now. I also want to not anchor this to the left, but instead anchor it so that it scales with the entire object. Something like this. Cool, that looks good, and we can just make sure that this snaps to the sides. Alright, so now when we go into the game, you can see that we have this cool looking bar, but we still need to animate this. So we need this to be controlled by the fuel amount that we'll introduce in a second. And to do that, I'm going to add a separate new component. You can see here it's going to be called player UI. And we're going to go new script, C#, create an add. Now let's double click this to open it up in Mono Develop. What we want to do here is first off import. Actually, we don't need to import anything because we're just going to be using a rect transform to do the scaling, and that's included under Unity Engine. So first off, let's add a reference, serialized field, add a reference to the fuel fill amount. So the actual object that we just created, that's going to be, it's going to be this one, thruster fuel fill. And this is just going to be the thruster fuel amount or fill or whatever. That's going to be, let's do fill. And then we want to add a public or just a void. Let's just do a void, which is going to set fuel amount on the UI here. And that's going to take in a float, which is going to be the actual amount. And what we can then do is simply say that thruster fuel fill dot local scale equals a new vector 3, where on the X we want a 1, on the Y we want the amount, and on the Z we want a 1, 2. You can also input the current local scale here instead of just the ones, but since I don't think we're going to be changing that, this is going to work just fine. It's going to run a tiny bit faster. Good. So now that we have this, we should be able to just call this method whenever we want. However, we don't currently know what the current fuel amount is both because we don't have a reference to our player controller, but also because we kind of haven't made the variable yet. So let's go ahead and do that. So in our player controller, let's go up here where it says thruster force, and let's add another serialized field. This one is going to store a private float, which is going to be the thruster fuel regen speed. Something like that. Actually, let's start off by doing the burn speed, how fast we burn through it, I don't know. This is going to be fine. And we're going to default that to something like 0.9 F or 1 F or whatever you want to do. So that means that it will be gone after 1 second of flying. Then we can make another serialized field. Private float, thruster, fuel, and this is going to be the replenish speed. I'm going to call this regen speed, and it's going to be set to something like 0.3 F. So we will gain back the fuel a lot slower than we will burn it. And then we can have a private float, and this is going to be the actual thruster fuel amount. And that's going to be default. That's going to default to 1. That means the maximum amount. Then we can go down into our update method, scroll down to where we handle some of the thruster force. You can see here, calculate the thruster force based on player input. Well, what we want to do here is we want to also, and I'm just going to do this up here. Whoops. We're going to want to say that thruster amount, thruster fuel amount, minus equals thruster fuel burn speed times time.delta time. So how much the fuel amount decreases when we are actually flying depends on the thruster fuel burn speed, and of course we want to make that frame rate independent. Good. I apologize for my English there. So we can take and do the same down here. So we simply want to say thruster fuel amount plus equals thruster regen speed times time.delta time. So here we will gain back thruster fuel at the rate of the thruster fuel regen speed, and of course again frame rate independent. So that's kind of how we do this, and you can see of course this means that we are flying and this means that we are not flying. So that should work just fine, and we don't only want to kind of limit this, we also want this we don't only want to control this variable, we also want to actually make this limit whenever we can fly. So we need to add an and here. So we don't only want to fly if we get the button down jump, we also want to say that thruster fuel amount needs to be larger than 0. So we need to have some amount of thruster fuel in order to fly this frame. Good. So that's perfect. And the last thing that we want to do here is we want to make sure that we clamp this value between 0 and 1, because right now when we are not flying, this is just going to increase and increase, and then when we actually decide to fly, we can maybe fly for hours, and that's not something we want. Also, it can go below 0, so if we keep flying, can it actually? It might be able to go just under 0, but then we will be stopped. So, but still we want to clamp this. So we want to say that our thruster fuel amount equals math.clamp, and the number that we want to limit is the actual thruster fuel amount, and we want to limit it between 0 and 1. There we go. So this should work just fine now, and we can actually start to tie this together with the actual player UI. So we have this system working, we have this system working, now we just need to tie them together. And we do that by kind of creating a link from the player UI to the player controller. So we can call a method here that checks what the current fuel amount is in the player controller. So let's start by adding a getter here, getter method. So public float get thruster fuel amount, and this is simply going to return thruster fuel amount. There we go. And again, the reason why we don't just make this public is to make it more protected, so that the only thing controlling this is the actual player controller. It just makes more sense doing it this way. Then in the player setup, or in the player UI, I should say, we want to have another public method. We want here a public void, and this is going to be a set player controller, or just maybe set controller. And this is the reference to our actual controller. So we want a private player controller, and this is just going to be the controller. And then here we can use this as an argument. So it's going to take in a player controller underscore controller, and we're going to set controller equal to controller. Perfect. And now we can use player setup to link these together. So in the player setup here, down under the start method, where we create this player UI instance, and remember, this requires that we are the local player, so we make sure that way that this is only happening for the local player that we want this UI to be displayed on. And what we can do here is first we create the player UI, then we configure player UI. And we do this by saying player, we create a temporary variable called player UI, and this is just going to be the UI component on that player UI object. And we set that equal to player UI instance dot get component of type player UI. And of course, we aren't certain that there's going to be a player UI component on that instance. So we want to say that if UI is equal to null, well, then something has gone terribly wrong. So we want to say debug.log error, no player UI component on player UI prefab. There we go. And if that doesn't happen, what we want to do is we want to say UI.setController, and we want to set that equal to the current controller, current player controller that sits on the same object as this player setup script. They are always going to sit on the same object in our game. If they aren't in yours, you should create a reference, just a variable here that you drag in the inspector. But here we're just going to require it as a component that a player setup requires a player controller. There we go. It's that easy, and this way we don't need to do any error checking. And that was it for this, I think. Then in the player UI, we can go ahead and make an update method. And I'm doing it this way because we could actually go ahead and make some kind of method call that makes sure it only updates whenever the fuel amount actually changes. But since this is a very easy check, and since the fuel amount is going to be changing a lot of times, because it's almost always going to be either regenerating or burning, therefore we really don't need to do that. So in the update method here, we're simply going to say that controller dot get thruster force or thruster fuel amount. There we go. So this is our current fuel amount, and we can simply say that we want this to set fuel amount to that using our method down there. So we can simply wrap that in as an argument, and now things should actually be working, at least if we remember to fill out the correct variables. So in our player UI, we want to drag in the thruster fuel fill. We want to then hit apply and forget about this object for now. Then under our player, we want to, these variables look just fine, and nothing new under the player setup. So now everything should be working. And if we go in and hit play, land host, and try and thrust here, you can see that it's actually working. So that is just perfect. The only problem that we currently have here is that when we reach a zero amount of fuel, we can still kind of hang in the air, because every frame it replenishes just a bit of fuel, and then we spend it the next frame. And that kind of gives this weird looking behavior here, which is not really desirable. So an easy fix for this is if we go under our player controller, go down to where we check or where we decrease this thruster fuel amount, we want to do that regardless. If it's over 0, we want to always do this. However, we only want to add thruster force if thruster fuel amount is greater than or equal to a very tiny amount, something like 0.01. And that's just going to give a tiny margin that will make sure that we don't apply our thrusters unless we have just a bit of fuel in the bank. So when we now go ahead and hit play, you can see that we just fall down if we don't have enough fuel. So that's just perfect. So now our fuel engine, so to say, should be working. Good. So the other thing that I wanted to fix is right now when we fly on top of an obstacle here, I'm just going to fly on top of this one. You can see that we collide with the ground. If I go into the scene view here, find our player, he sits on top of that thing, which he shouldn't. He should be floating. Actually, he is floating just a bit, but that's because of the collider is just a tad bigger than the actual player model. You can see that we are colliding with the ground here. And that's not what we want. So we kind of want to offset the level at which our spring will try to reach. So in order to do this, if we just, actually let's just hit play here and I'll demonstrate. When we spawn our player in, we spawn him at a Y position of 1. Then what we can do is we can kind of move him around on the Y, which we do, and then it will try to reach this 1 position again. And you can see it gets very, very close. However, whenever we were standing on top of an obstacle, we want to keep kind of change this ground level. So we don't want him to strive to be at 1, we want him to strive to be at that obstacle's top position plus 1. And if we go under our configurable joint, we have something called a target position, and that is that exact offset. So let's say that we jump on top of a 1, 1 cube. Well, then we just type in 1 here, or I'm sorry, -1, and you can see that offsets his new ground level. This way, what we can do is we can simply fire down some rays, so we can use ray casting to check how far above any obstacle or ground we are, and then set that position in negative down here. So that's what we're going to do. If that was very complicated, don't worry. It's very easy to do in code, and you can just write after me, and you'll see just how cool it looks when we are actually done. So let's find our update method here. We can just do it at the very top, and this is something that we want to be doing every frame. So in here we can first off do a raycast hit, and this is just going to store information about what we hit, where we hit it, and stuff like that. Then we can say if physics.raycast, and then we want this to give this a bunch of variables. The first off, you can see many different versions of this. The first off is going to be the origin, so we're going to be using transform.position. Then we're going to give it a direction, which is going to be vector3.down. It's always going to shoot directly down. Then we are going to give it a out hit, so we want to fill information about what we've hit into this variable here. That's going to feed that in there. Then we are going to give a maximum distance, that's going to be 100. And finally, we can do a layer mask, which we'll do in a second. So if we actually hit something, this is going to return true, and therefore this code down here is going to be called. And if it has, well, then what we want to do is we want to say joint.target position. Here is going to be equal to a new vector3, and it's going to be 0 because we don't want any offset on the x. Then we want something on the y, and it's going to be 0 on the z as well. And what we want on the y here is going to simply be the point that we hit, so the very surface that we hit, that exact point dot y, and then of course we need to inverse this because it's a negative offset. And that's all. That's all we need to do. And if we haven't hit anything, we're simply going to set this target position equal to the ground plane. So that's going to be 0, 0, 0. There we go. That's all. I hope. And if we go in and try this now, or maybe we should just comment what we're doing here. So we are setting target position for spring. This makes the physics act right when it comes to applying gravity when flying over objects. Good. So that should be working, and we can now jump back into Unity. And if we just try this out, everything should be just fine, because we don't have a problem with the raycast hitting our actual objects, or that at least we shouldn't have. And the first thing that you will notice here is that this works just fine. And if we go over to this object, fly on top of it, you can see that we are hovering over it, and the physics feel a lot nicer. You can see here we are actually hovering there. So that's just perfect. And if we go jump off the ledge here, you can see just the same thing happens. So that's just perfect. And the last thing I want to do is just to make sure that this is a bit more configurable, add in the layer mask anyways, just so we can have objects with colliders that we aren't actually able to stand on top of. So a cool idea for this would be a player. So you can just make like a player tower or anything like that. You can if you want to, but I don't want to. So let's go up here and under, maybe just here. We could put this under spring settings, but I don't really think it should be under spring settings. And this is just going to be a serialized field. It's going to be a private layer mask. And it's going to be called environment mask. That will make sure we only collide with the actual environment, and we can just add this here as the last argument in this crazy row of parameters. And then we are going to go under our player, and you can see here we can now select any layer that we want. So I'm going to make a new layer here. I'm going to add a layer, and this is going to be a collidable environment. Let's do that. That's going to be stuff like obstacles, ground planes, stuff like that. Then let's go under environment and select all of our cubes, not the directional light. And let's change them to collidable environment. Cool, save that. Select our player and then choose as the environment mask. Remember to choose collidable environment, and you can check off any other thing that you want this to be able to collide with on the y-axis, or I should say able to hover on top of. It will still be able to collide with everything else. Also, now you need to, of course, make sure to change the layer of any object that you want this to be able to hover on top of, but that should be just fine. If you remember to do that, this system is going to work so great. So now when we play, we should see absolutely no difference. Things should be working, but it's more stable now and we have more control. There you go. So that was basically it for this video. I hope you enjoyed it a lot, and I'm definitely looking forward to the next one. So thanks for watching, and I'll see you in the next video.